Good evening, everyone. I hope my screen is visible. Sorry for the small delay. Actually, there is some internet issue in our campus, due to which I had to restart my computer. So, welcome to the week 7 of the course Nanotechnology in Agriculture. My name is Amit Akle. I am the teaching assistant for the course. I am a PMRF in the Indian Institute of Technology, Tirupati. The course instructor for this course is Professor Mainak Das, who is the professor in the Department of Biological Sciences and Bioengineering, IIT Kanpur. So, without much ado, we'll just start with this week's content. Uh, like these are the basic formalities which we have every time. This is the YouTube link. This is the YouTube link for the channel link for the YouTube channel. So this is a 8 week course. This is the seventh week. So you are in the penultimate week. So next week we will be having two classes. One will be the week 8 class and one will be the revision class. So you will get the email soon. So the week 7 content is basically nanotechnologies for water quality and availability. Um, so let's start. So the first question is, ilmenite is a source of dash. So it's at carbon, cerium, titanium, gadolinium. So basically, what the question is asking is ilmenite, which is a ore. What is ilmenite a ore of? So basically, uh, the answer is this is the composition of ilmenite. So basically, you have titanium at 41 weight percent, iron oxide, that is ferric oxide at ferrous oxide at 44%, ferric oxide at 28%. So total iron content is around 39%. So then these are other materials by the weight percent. So what do you think will it be the source of? The answer is titanium. So basically, is the ore of titanium, and it is also sometimes used for extraction of iron. So the thing is, well, this is a bit of more of chemistry. So what happens is iron and titanium we will always find together. So the ores of iron and titanium will always be found together. So even when you are extracting anything from iron ore, you will get some trace amount of titanium. So basically, when the formation happens, iron and titanium you will find together. So that is why you will always find iron with titanium in the natural like in the natural context per se. So we move to the next question. So that is measurement of dash provides valuable information on the surface properties of nanoparticles, especially when ionic surfactants are used to stabilize the formulation, particle dispersion, mo- atomic radius, molecular friction, zeta potential. So the answer is zeta potential. So basically, what is zeta potential? Is basically you have an atom. You have this layer, which is the strongly bonded electron. So basically, you have the atom, you have the nucleus, and you have the strongly bonded electrons, and then you have surface level ionic ions, basically, or what you can say. Like so, there's surface charges basically happening. So what zeta potential does is zeta potential finds the what is the charge distribution in the electrical double layers. Basically, how when you are having this electrical double layer, uh, what zeta potential does is it finds the charge distribution, what is the charge. So what happens is zeta potential is basically also shows how much stable the particle is. So higher the zeta potential, basically more energy is required to break this uh, inner uh, like the inner atom per se, or inner nanoparticle per se. So if you want to break the inner particle, you need higher force that is needed. So that is why you need to that zeta potential is a very important parameter that you need to calculate or measure while doing nano chemistry. So the third one, Dash works as a nanocatalyst in the degradation of methyl orange dye, cerium oxide, cerium, ferrous oxide, titanium dioxide, gadolinium. So the answer is ferrous oxide, titanium dioxide. So this is how it happens. So basically, where the metal nanoparticle, so that nanoparticle of ferrous oxide and titanium dioxide, basically it acts as a nanoparticle, and it absorbs the light, and it leads to surface activation, because anyway we had studied last time also that titanium dioxide is used as a photocatalyst. So basically that combination is used, and it acts as a redox reaction. So it will speed up the degradation of the speed up the oxidation of the methyl orange dye. Okay, so moving to the next question. Gadolinium belongs to dash series of the metals, and it is and in its free form is highly cytotoxic. Lanthanide, inert actinide, group 2. So the answer is lanthanide. So this is the periodic table. So group 1 is the alkali metal, group 2 is the alkaline earth metal, then group 3 is the boron group 4 is the carbon group 5 is the nitrogen group 6 is chalcogens, which is the oxygen group 7 is halogens, and group 8 is the noble gases. And then there is the transition elements, and in the transition element there are two series. One is the lanthanide series and one is the actinide series. So you can see here the actinide series. In the lanthanide series there is the gadolinium basically. So the fifth question, basically, actinides are elements with atomic numbers from 70 to 90, 90 to 99, 80 to 99, 90 to 103. So the answer is 90 to 103. You can see here in the periodic table, the actinides, actinide, actinides are basically from 90 to 103. Okay, so question number 6. The basis for understanding muscle contraction is dash. The first proposed in 1954 both by Audrey Huxley and Ralph neither Gerke, and by Hugh Huxley and Jean Hansen. Excitation contraction, sliding filament model, topological mode, sliding model. So basically, this is something like a GK kind of question. So the answer is sliding filament model. This is how the model looks like. So basically, what happens is it considers the muscles into a filament. So basically, the, muscle is obviously we know it's a fibrous tissue. So what it does is it considers muscles as a filament, and then when we actually give any uh, signal, basically what happens is uh, the myosin head splits and ATP becomes reoriented and energized. So then once the ATP becomes energized, it binds to it forms a cross bridge. The myosin then heads rotates, and so then basically once it has bonded, once it has formed a cross bridge, there is rotation happening. There will be like towards center of the sarcomere. So once the cross bridge has been formed, there will be a rotation and it will move towards the center. Then again there will be uh, there'll be detachment from the cross bridge, and then again it will be like the cycle will go on continuing. So that is called as the sliding filament theory. So, moving to the seventh question, contraction of skeletal muscle is triggered by the nerve impulses which stimulate dash from the sarcoplasmic reticulum, so a specialized network of internal membrane similar to endoplasmic reticulum that stores high concentration of of calcium ions, release of calcium ions, release of sodium ions, release of potassium ions, release of magnesium ions. So the answer is release of calcium ions. So you can see here what happens is the entire cycle continues if ATP is available and calcium level in in the cytoplasm is high. So basically, what happens is the neurons give a signal to the sarcoplasm, which increases the calcium level, and that actually leads to the entire cycle going on. So that is why release of calcium is very important. Question number 8. It has been observed that dash of ZNO can be demonstrated likewise in dark, inhibiting bacterial growth, inflammatory muscle growth, antibacterial activity, and anticoagulant. So here, basically, we don't even need to think anything. They have already given here that inhibition of bacterial growth. So obviously, it will be antibacterial activity only. But we'll see how actually the antibacterial activity works. So basically, whenever zinc oxide nanoparticles are used, it will have three-pronged approach. So there will be release of reactive oxygen species. So basically, I mean, there is a release of reactive oxygen species. They create an oxidative stress on the bacterial cell membrane, which in turn leads to killing of the bacterial cell membrane. Then there is again release of zinc ions. So basically, what happens is zinc ions disrupt the sodium potassium pump, which we studied last time. So basically, that is disrupted by the zinc ion. So basically, zinc passes through it and it disrupts the pump. Basically, that is what you need to know. And then the third is basically when it comes in direct contact with the cell membrane, also it leads to the like bursting of the cell membrane. So it affects the cell membrane at three levels, which leads to significant antibacterial activity. So, question number 9: nanoliposomes are among the most investigated dash in cosmetics and food industry. Nanoenzymes, nanocarriers, osmotic regulators, moisture capturers. So basically, the answer is nanocarriers. So this is how nanolysome works. So a nanolysome is loaded with the compound. So basically it is loaded with all the phytocompounds, and because of its size it is able to penetrate inside the skin layer, and once it goes inside the skin layer, it releases the drug, which leads to you getting a good result. So basically that is how the entire mechanism works. So the last question, nanomilling is a dash process by which the industry can minimize on the nanoscale the size of of poorly water soluble active ingredients, increasing the surface area and consequently increasing the rate of dissolution. Top down approach, bottom up approach, gravimetric approach, or density gradient approach. So it is a top-down approach. So basically, top-down approach is basically you break down bigger parts into smaller parts. So that is what happens in nanomilling. So basically, it is called as a top-down approach. Any questions? Any questions? Um, Please free to ask. Please feel free to ask. In case not, you are free to leave the session. Yes, sir, Debrata, sir.
Sir, can you repeat from one, sir?
Yes, sir, sure, sir. If other people, if you don't have any doubt, you are free to leave. Okay. So, so the first question is: ilmenite is the source of dash, carbon, cerium, titanium, gadolinium. So ilmenite, this is the composition of ilmenite. Ilmenite is is a very common ore. It is used for ferrous extraction as well as titanium extraction. So basically, this is the composition. So titanium dioxide is 41%. Ferrous oxide and ferric oxide is basically total comes to around 39%. Then you have other trace elements, obviously. This is a widely used ore for titanium extraction, and also residues of iron that are formed that are also used for iron extraction. So it is very commonly used. It is found in lot of states in India also. So it's a very commonly used material. So ilmenite, the answer is ilmenite is a source of titanium. Um, Question number two, measurement of dash provides valuable information on the surface properties of nanoparticles, especially when the ionic surfactants are used to stabilize the formulation, particle dispersion, atomic radius, molecular friction, zeta potential. So the answer is zeta potential. So basically, zeta potential measures the strength of the electrical double layer. So basically, whenever a nanoparticle is present, that there is charge that is formed on the nanoparticle surface, because there is a surface charge, because there is a very high surface to surface area by volume ratio. So there is a high level of charge on the surface. So what happens is there is a like a opposite charge that is always still building. So like for the stability, there will always be a opposite charge. So when the opposite charge is there, so what is find so uh, this is so here you can see there is a nanoparticle. So because of its small size, there is a surface level charge that is being distributed over across the.
ছেলেটা দেখলাম মেয়েটার দিকে তাকালো, তাকিয়ে সামনাসামনি গেল, দেওয়া সরে গেল, সরে যে মেয়েটা ওই ফুট দিয়ে হাঁটছে, ছেলে দিয়ে আবার
Can I tell, sir?
Yes, sir.
First question, you are the limonite is the source of TiO2. In the
Yes,
sense,
sir.
there is no option for the FeO2.
Yes, sir.
Then, if there will be option of iron, then answer also will be the iron. Na?
If there is an option of, see, you can see here the percentage. If it is iron and titanium, still the answer will be titanium, because what will happen is iron is still less than titanium. So what happens is there are other ores of iron also, like ferrite and other ores of ions. But ilmenite is basically more preferred for titanium extraction. So now when you are extracting something, when you have ilmenite, you will majorly focus on extracting titanium. You will not focus on extracting iron, because iron you have other ores which are more iron rich. So ferrite is more iron rich compared to titanium. So it's you will always prefer like ilmenite for titanium extraction.
Sir, this type of ore available in which part, sir?
It's there in like Karnataka. There are some districts. I am not quite sure. Some, but it is there. Like in Karnataka, some districts you get. Which district? I am not very well aware. But this is widely used. But we use it main for titanium. So in India, mainly you will get ferrite ore. So ferrite is you'll get in the parts of Goa, Karnataka. From there, it is being distributed. Um, you also get it in Chhattisgarh, ferrite.
In Odisha
Ilmenite is,
also?
huh?
In Odisha also, no, sir?
Yeah, Orissa also. Like, I'm not very well aware of that, but just I have just surface level knowledge. So you get it there, and basically for titanium extraction you use ilmenite because titanium is so earlier titaniums there was not very highly used because titanium is very difficult to machine. So titanium you cannot machine it. So now because of 3D printing, basically your titanium has gained a lot of significance. So because titanium alloys are highly biocompatible, and it is used in implants and all those things, prosthetic. But earlier titanium, since it is very difficult to machine, the applications of titanium were quite low. So
Yeah.
now we are using it, and ilmenite is a very good source. Even if you look at it, it is not a very cost effective method, which you're just getting 41% ilmenite. If you go with ferrite and all, you'll get
Ah.
83 to 90% of iron you will get in ferrite. So it becomes very cheaper to extract. Whereas in titanium's case, even here it is a lot of wastage will happen. So that is the case.
Okay, sir.
So you need me to move to question two, or others you have done seen, sir?
No, sir. I have skipped already 1 to 7 questions, sir.
Okay, so one to
Because I
seven.
joined late.
Okay, I'll go with 1 to 7. Okay.
Okay, sir.
So this is the second question. So measurement of dash provides
थोड़ा सा
valuable.
2 मिनट एम आई और संपला को 2 3
Madam, you have any question, madam? Madam, do you have any question? Okay, I'll mute you for now and we'll move to the second question. So, measurement of dash provides valuable information on the surface properties of nanoparticles, especially when ionic surfactants are used to stabilize formulation, particle dispersion, atomic radii, molecular friction, zeta potential. So, basically, the answer is zeta potential. So, what is zeta potential? So, what happens is whenever a nanoparticle is formed, so there is a lot it is very closely bound. So whenever a nanoparticle is formed, it is very closely bound. So that what happens is because of that there is a lot of surface level charges. So basically to stabilize that, you need to put it in a solution like the surfactants, as we have written here, surfactants. So what happens is the surface charge are balanced by this electrical double layer. So basically all the charges that are there on the surface are basically balanced by the electrical double layer. So now what the zeta potential signifies is zeta potential signifies the strength of the electrical double layer. So now what does it mean? So when you have higher zeta potential, as we said last time, so the sign doesn't matter, the sign doesn't matter, the value matters. So higher the zeta potential, higher is the stability of the nanoparticle. So now what is happening is by measuring the electrical double layer, you get to know about so by measuring the zeta potential, you get to know about the stability of the nanoparticle. So valuable information on the surface property. So it gives you a knowledge about the surface charge, and also it gives you knowledge about the stability of the nanoparticle. So moving to the next question. Dash works as a nanocatalyst in degradation of the methyl orange dye, cerium dioxide, cerium, ferrous oxide, titanium dioxide, gadolinium. So the answer is ferrous oxide, titanium dioxide. So we have already had last week. We had already studied titanium dioxide is used as a photocatalyst. So here they are using it in conjunction with ferrous oxide. And what is happening is basically the sun is coming, that is exciting the metal nanoparticle surface, basically because it's because of the titanium dioxide catalytic properties. It is exciting the surface, and that leads to like catalytic behavior, and that leads to reduction of the methyl orange dye. Okay. uh, so the fourth question. Gadolinium belongs to dash series of metals and in its free form is highly cytotoxic. Lanthanide, inert actinide, group 2. So the answer is lanthanide series. So here is the periodic table. So you can see here the group 1, then that is called alkali metal. The group 2 that is called as the alkaline earth metal. Then group 3 which is the boron group. Group 4 which is the carbon group. Group 5 is the nitrogen group. Group 6 is chalcogen or the oxygen group. Group 7 is the halogens or the fluoride group, and group 8 is the noble gases. Then there is a transition element. These are basically uh, group uh, uh, group 3 to group 12. In the transition elements, in the second last and the last column, so you have two more groups. So basically these are the lanthanide group and the actinide group. So basically in the lanthanide group we have gadolinium, and these elements are basically highly radioactive. So you can see here uranium is there. You have various other materials which we already know are used in radioactive materials. So like these are not very stable elements. So even gadolinium is not. That's why gadolinium is very highly cytotoxic in its like normal. If you get it as a uh, pure element. So in its free form, it is highly cytotoxic. So that is how it is the use. So question number 5: actinides are elements with atomic numbers from 70 to 90, 90 to 99, 80 to 99, 90 to 103. So the answer is 90 to 103. You can see here the actinides. The group they go from thorium to basically yeah they start from thorium to atom material with atomic number 103. Okay, moving to question number 6. The basis of understanding muscle contraction is dash first proposed in 1954 both by Andrew Huxley and Ralph Nieden-Gerke, and Hugh Huxley and Ian Hansen. Excitation contraction theory, sliding filament model, topological mode, excitation sliding model. So the answer is sliding filament model. So this is a GK kind of question. So this is how the sliding filament theory works. So basically, what happens is there is a release of ATP, that is the energy, that is adenosine triphosphate. So that is the energy molecule inside our body. Then because of that, then there is a binding between the two filaments, that is a cross bridge is formed. Then it tries to go back to the previous form, so that the cross bridge detaches from the actin, and then that is how one movement is happening. Like if there is a lot of ATP and a lot of calcium, this movement will go on happening until the entire fine you reach the final destination. So that is how it works. So what happens is your neurons basically release ATP and calcium, and then based on the amount of calcium present, the the number of
Chat.
motions, there will be that many number of motions actually. So move to the next question. The contraction of skeletal muscle is triggered by nerve impulses which stimulate the dash from the sacroplasmic reticulum, or specialized network of internal membranes similar to endoplasmic reticulum that stores high concentration of calcium ions, release of calcium ions, release of sodium ions, release of potassium ions, release of magnesium ions. So as I said earlier, what will the neurons do is neurons will release in the energy as well as trigger calcium release. So basically depend on the how much calcium release is going on, the movement will be that much. Okay, so that is how the thing works. So if you have that is why if you have calcium deficiency, you have like muscles. You have difficulty in doing a lot of movement. So that is why calcium is a very important organ element inside your body. Question number 8. It has been observed that the dash of ZNO can be demonstrated likewise in the dark, inhibiting bacterial growth. So the answer is antibacterial activity. This is how the antibacterial activity of zinc ZNO nanoparticles happen. It releases reactive oxidative species. It releases zinc plus ions. It also comes in direct contact with the cell membrane, bursting the membrane. So basically, all these three pronged approach leads to better antibacterial properties. Coming to the question number 9, nanoliposomes are among the most investigated tasks in the cosmetic and food industry. Nanoenzymes, nanocarriers, osmotic regulators, moisture capturers. So the answer is nanocarriers. So this is how they work. So nanoliposomes are loaded with the photocatalytic materials, and then they basically penetrate inside the skin, and then there's a release of the drug inside the skin tissue. Moving to question number 10, nanomilling is a dash process by which industry can minimize the nanoscale on the nanoscale the size of poorly water soluble active ingredients, increasing its surface area and consequently increasing the rate of dissolution. Top down approach, bottom up approach, gravimetry approach, density gradient approach. So the answer is top down approach. So basically in nanomilling you have a bigger material which is then crushed into a smaller nanoparticle. So that is why it is called as a top down approach. So any questions?
Okay, sir.
Okay, so yeah. So if you don't have any question, you are free to leave the session.
Sir, I have only one question, sir.
Yes, sir. Yes, sir.
Professor Pratik Das will be available in live session or not?
Uh, I I think so. If it was there, no. It will be. I think that there will be one session before the exams. Have the exam dates come, sir?
It is 22.
Okay, so 22. Sorry, let me check. So 18th are the last session. Mm-hmm.
And it is the last session of you, sir.
Yeah, 18th will be the last session. So 18th is the last session. So mm, if at all,
22 is
if at all it is there, it will. I don't think so. There will be any session, sir. But still, I'll try to mail them and ask them, sir. I'll try to mail sir and tell them that you have some queries. So usually, what happens is the session will happen during the business hours. So that is the when the faculty is working, and that time no student joins actually. So that is why they stop
actually, sir. I
taking.
have no. I have done, sir, so many courses from NPTL.
Yes,
Every professor doing the online
yeah. No,
session
not every
for
professor.
one
It
or two times.
depends on the professor. It happens. So basically, it is upon the
We have
demand.
some,
So
oh, no, sir. Only we have some aspects from them also. We
yeah, yeah.
have want to know something from there also.
Yeah, exactly. I understand that. So maybe I'll write a mail to sir, and let's see how if he responds positively.
Okay, sir.
So you'll be
May I
able to,
speak, sir?
you'll be
The-
fine if it's in the working hours, right?
Now,
No, no. If it is in the working hours, so 9 to 5, if it is there, it will be still be fine, right?
yes, yes, yes.
Okay.
Whenever
Then
it
I
need, actually, is that kind of professor is giving some half an hour or 1 hour any time, it will be valuable for us, sir.
okay, sir. So then I'll send an email to sir, and let's see if he responds positively.
Okay, sir. Thank you, sir.
No problem. If you don't have any question, you are free to leave the session. If you have any
No, no,
questions,
no, no, sir. I skip, sir.
okay. Thank you, sir. If you have any doubts, else you are free to leave the session. हॅलो. हॅलो. हां. अरे मजेत आहे. काय झालं? एक सेकंड. I like to, since there are no other question, I would like to thank you all for your participation, and we'll see you next week. Thank you.